So we're going to start out building the frame of the 3D printer, which consists of 3 aluminium parts. Nothing hard to do here. We do need to take the part that holds the other 2 profiles and drill 2 holes into that one. And for the 130mm 3D printer, we're going to drill 1 hole at 130mm and the second hole at 200mm, starting from the front of the printer. So we measure 130mm here, 200mm here, and we need to drill this in using a drill press. The drill hole should be pretty good because we are going to use some M6 threaded rod and 2 M6 screws to tighten this down. Also, now would be a good time to cut the M6 rod to a length so you can thread it through the whole length of the Y-axis profile until it reaches out at the end, so it should be a bit longer than that. And another part that goes all the way through the Z-axis parallel part that we're going to screw down then. Basically, the screws are then recessed in the holes within the profile, so they won't protrude through this profile, but they will be visible at the end, but that's not so much of an issue. Also, we can prepare the feet. For the feet you need 2 M5 screws and 2 M5 T-nut screws, and that's it. So first order of business is to drill the 2 holes in this part and to make 2 parts of M6 threaded rod, so it goes all the way through and halfway, and more than halfway through the part holding it. Yeah, I'm gonna get this done. So once we're done drilling the holes and getting everything cleaned up again, we thread the M6 rod into one of the profiles and have it come out at the end of the other profile. We screw that nut in first, making sure that it's recessed within the recessed space inside the profile, and then we tighten the other nut, holding the whole structure down on a table to make sure that these 2 parts here are perfectly in line. And once you tighten that down, this shouldn't move anymore. Don't overdo it, but it should be really nice and tight. If anything happens to the 3D printer later on, you can always retighten this, loosen it up, get it back in line, retighten this. It's pretty important that this continues to be able to move. If you're quite certain that you're never going to have to release this again, you can use some glue on this joint, but I don't do that. It works perfect without. Also, I've got all the feet added inside the profile, which is pretty cool, and we've got the whole frame ready to go. So this brings us to the point where we mount the Z-axis idler. There are 2 choices here. You can either use this black part, which has the recess for the bearing, but in order to use that part you need to have a threaded rod that has a slight step machined into it. Some companies where you can order those will do that for you, but not a lot of them. And for everybody else who doesn't have a lathe or somebody who they can ask, if they would lathe the threaded rod for them. You can just get a plain cut piece of threaded rod. This is TR8, and make sure that the cut on the end is very flat and perfectly perpendicular to the rod. This is very important in any case. So make sure you get these pieces with good cuts, and if you have to cut them yourself, make sure that you use a grinder or something to make this perfectly flat and perfectly perpendicular to the rod. You're going to run into troubles otherwise with the Z-axis. Now, if you chose the part with the recess for the bearing, you can put away the rod now if it has the machine step in it. If not, you also need a small ball bearing ball, about 4 to 6 millimeters. This one is about 5.2. And what you need to do is you need to drop this bearing ball, once you mount it, into the small hole inside the Z-axis idler with the no bearing option. And the threaded rod is going to sit on the ball bearing ball, and the movement is about just as fine as with the bearing, only you need to make sure that this thing stays somewhat lubricated, and you need to keep it cleaner than the bearing variant. But apart from that, all is the same. So you need to have a decision here, and once you're done, use a M5 T-nut to mount this to the Z-axis. Make sure to mount it all the way, and make sure that you have this little ball, because you're going to want to drop it in there. And when you mount the threaded rod, it's going to sit on the ball and it's going to turn nearly perfect. So that is a very cheap way of getting by the bearing and the machining of the threaded rod, and it works just as fine. So to mount this part, I'm going to use the M5 screw and a fairly large washer. I made sure that the holes in the 3D print fit the screws that I'm using, and I'm just going to make sure that this goes in all the way. Then I'm going to add the T-nut and slot it in from the side. This is one of those self-fastening nuts, so it'll turn in place. If you don't have one of those, you can just slide it in from the top until it's all the way down. This is really simple. So the next thing that we're going to add is the holder for the RAMS board and the Arduino. To do that, we need 4 M5 screws and we need 4 M5 T-nuts. With these, you don't need to tighten this down so much, so you may forego the washers. Use them if you want to, but you can leave them off. You don't really need them, because once this is tied down, this is not going to open up, and it doesn't have a lot of load in it, so you're good to go without. This actually mounts towards the end at the bottom of the 3D printer, and I'll just mount that now. Oops, sorry. So now that we've mounted the holder for the Arduino and for the ramps board, we can start building one of the mounts for a slide, which is the mount for the Y-axis. I've already started on this. First of all, you need to make sure that all the holes are clean. Don't use a drill, use a screw. Put a screw in there and make sure that you can move it in there, pull it in, push it out. Make sure that the heads for these small screws go in all the way and that it's reasonably easy to turn them when they're in there. Same for the hex screws that need to go in there. They should be in there, but they should be able to move a bit, and it should all be relatively easy to put together. You will need to cut these screws because they are M5 with a length of 22 millimeters, and these are extremely hard to get. I use M5 by 20s and I just cut them until they're 12 millimeters. The M3 screws in here are M3 by 14. You can also get away with M3 by 12.5 or 15. Yeah, that is important. So once you have everything cleaned up, the surface here should be clean, the surface on the underside should be clean. You should not cut these screws while they're in the 3D print so it doesn't heat up. That's the same reason why you shouldn't use a drill, because if the drill heats up, it's going to deform the plastic and things are not going to go that well afterwards. So, screws are in here. We also need 4 bearings. These bearings have an inner diameter of 5 millimeters, an outer diameter of 11 millimeters, and a width or thickness of 5 millimeters. I'm going to start by adding one set of nuts to the screws holding the bearings. And these are going to make sure that the screws stand at a pretty good 90 degrees to the rest of the board. No, this one doesn't really like me. Is there shaving left from the cut? Yeah, possibly. I'm going to have to clean that up. Be right back. Okay, back all cleaned up and ready to go. This is better, I hope. So I'm going to tighten these down with a reasonable amount of force, not too hard, but not too soft either. And when they're perfectly parallel, I'm just going to leave it at that. There's going to be some load on these from the belt, but it's not going to be too much. After that, each of them gets 2 ball bearings. There should be about 2 or 3 threads at the top. If it's less, then your screws are too short. Right. But it's very important that the screws do not protrude out of the nuts at the top, because then it's going to interfere with the table, and of course we don't want that. So the bearings are moving nicely, and yeah, that is that. So we now have 4 bearings mounted on the motor holder. Now I'm going to add the slider, and this needs to be tightened down really carefully. Two screws at a time in a crossover manner. If you would be numbering them, then it's 1, 3, 2, 4. And you want to take your time doing this. Don't rush it, because you do not want the bore in the plastic to deform. You also don't want to put any excess stress on the plastic part, because it's going to be holding your table afterwards. So we're going to go for a reasonably tight, not too much, not too little. And done. So I picked a linear slide that is, well, not really moving, absolutely super easy. But it has a lot of tension on it, and there's no flex in the slide. If you have a slide which has a very slight amount of flex, or where the balls aren't moving along, although it is moving really easily, use that one for the x-axis. That one is the most forgiving. The z-axis can be a really tight slide. It doesn't really mind that much. But the y-axis should be one which is a bit tight, but it shouldn't be a loose one. So yeah, you have to keep an eye out for that. After that, we're going to use some M6x20 screws, some washers. Once again, I use very large washers because I want to spread the load on the plastic part. And we need some T-nuts, and we're going to mount this using 3 screws. Did I just say 2? It's 3. And these get a corresponding T-nut on the other end, and we're then mounting them onto the table with the stepper to the lower right side. So back side on the right side, opposite the ramps board, that is where the stepper should go. For this purpose, I'm using the slightly larger T-profile nuts, which they have got an extra spring-loaded ball, so they won't turn around or get away, and they fasten the part as you tighten it. So that's it. You want to put them in this orientation. They should be facing always towards the linear slide. That just makes sure that we get a good load on this. Alright, that's it. I'm just going to tighten this down very slightly. I'm not going to put it into its final position yet. That is a step left over for later, when we've got the table on and when we can make sure that the table is 100% under the moving area of the x-axis. We can tighten this down slightly, but there's no need for that. We'll also get to the stepper later on, so everything's good for this part. You might want to put something into the end holes, like a screw or a cable tie, so this thing can't get away. So here we go, next part mounted. Okay, moving on to the next part. This is the stepper holder for the x-axis. This here is the linear slide and block for the x-axis. And we need to mount this to the x-axis, and the other block is going to be mounted to the z-axis linear slide. And that is really easy. We just need to make sure that the groove that was made for the slide fits snugly. We leave the first hole empty, so that is not used. And then from the back we thread an M3 by 30 through the hole from the back, out through the front. We take one M3 washer, put it across here, and just tighten this one down. You can use thread lock if you wish, but I found it's not really necessary. And we can tighten this one down really well. And we have another M3 by 30 which goes into the hole adjacent to that one, and which also gets a washer and an M3 nut. And we can tighten that one down as well. The last one gets an M3 by 18, I believe. So look, this is an M3 by 16, it's the wrong one, but... Oh, an M3 by 16 would work out too. But I suppose an M3 by 18 would be better. Yeah. And we add another nut here. And why is this not catching on? And when we have this one tightened down, the part is done. And we're going to mount this onto the Z-axis linear rod, linear slide next. So here we have the Z-axis linear slide and block, and we're just going to screw this on like this. And like before, we're going to go in a crossover pattern. Although that's not really necessary. We could just force these in. And here we go. We can tighten this down pretty good. And we're done with the movements for the X and Z axis. So for the next step of mounting the Z-axis to the frame, we need two M3 T-nuts. These can be really hard to get, and two M3 10mm screws. And we're going to screw one of the T-nuts in the next to last hole of the slide. And the same goes for the second hole on the rail. Then we get the frame of the 3D printer. Let's put it down like this. Here we go. And we're going to thread this from the top into the printer. and we're going to just gently mount it about 5 centimeters from the Z idler, and we're not going to spend a lot of time getting it centered because we'll need to do that in the end. We just make sure that it's mounted kind of good so nothing can happen, and just to make sure that this can't go anywhere, I'm going to stick a cable tie in here, so once this goes down, this won't go nowhere. And now we've got the Y-axis, the X-axis, and the Z-axis already mounted. That's how simple it is. Let's continue. So the next thing that we need to mount is the Z-axis stepper holder, which just goes over the top here. It can be quite fiddly to get in, but I prepared this so it would slide in easy, and that's exactly what it does. We can tighten this down some, but we're going to have to do it again when we set it up and when we add the threaded rod, so we can just leave it on so it doesn't fall off. We don't need to tighten it down really well. It's we'll do it later, but we need to, or we can put it on because all the parts that we need on here are now mounted. Next thing that we'll mount are the belt holders for the X-axis, which we're just going to stick on with 1 or 2 M3x30 screws. They're going to stick out right until the end, until we mount the extruder. And we're going to do the same for the belt holder for the Y-axis, because we need them mounted to cut the belt, but we're only going to tighten them down once we mount the table. So I'm just going to get some screws, stick them in here, and I'm going to put some nuts on them. So here's the second belt holder part, and we're just going to prepare that, because when we do the belts and when we get everything set up, we're going to have the steppers in there. Once we have the steppers in there, we want to take care of the cabling, and we need to have some room to add the homing switch, and all these things still need to be done, so it's okay if we just put them on so they are where they're supposed to be, and we don't need to move them anymore. Here we go. That's the Y-axis. Just one big screw for the belt holder for the X-axis. There we go, it's not going to fall off. And then, as a last part, we are going to add the idler for the X-axis. I put a piece of tubing in here. Just take that out. It's pretty nice to have something in the rails so that the carriage doesn't slip out. And I'm going to tighten this down with 2 and 3 screws, and then this thing can't get off anymore and we can start working it. Okay, for the next step we are going to add the bearings to the X-axis idler. For that we need 3 M5 by 20 millimeter screws. We need 4 bearings. We need 2 washers. These washers are 5 millimeter inner diameter, 10 millimeter outer diameter, and you should make sure that whatever size they are, their outer diameter should be smaller than the diameter of the bearing. The whole thing is pretty simple. Just insert the screw, add a bearing right next to the plastic. If these washers have indents, make sure that they don't go into the bearings, or the bearing won't really want to spin. Add the 2 bearings and finish it off with a nut on the back of the screw. After that, tighten this down firmly, but don't destroy the plastic. Make sure that the bearings are still running, and continue with the second hole here. Nice. The third screw for the third hole in the idler, we're just going to put this in here and add 1 nut to keep it from falling out. Well, it's not falling out anyway, but we're just going to add 1 nut here. There's going to be a large washer on that to make sure that the belt can't jump off the bearings. Sometimes you need that, sometimes you don't. I like to put this on, so because it's quite bad when the bearing when the belt just jumps off the bearings, and we can make sure that that doesn't happen. So once again, that's it. Next step done. So we head on to the next part, and this one is a little bit more complicated. It is the TR8 nut that is going to go with the threaded rod, and there's a small plastic part that goes over the TR8, and it is very important that this is on really well. It takes a bit of time to get this till it fits the nut exactly. This part is needed because when the rod has a little bit of play or a little bend, which happens pretty often, you do not want it to translate into Z-axis wobbles. So what you need to do is you need to put on this little bracket, and you have the guide for the threaded rod, and the two of them go together like this, and you need another screw and nut to hold these two together through the hole at the top. This is an M3 by 18 millimeter nut, and I'm going to use a lock nut at the top so it doesn't come back off. You can use a normal nut if you don't have a lock nut. And these two parts make sure that there can be a little bit of movement in the nut, and it doesn't get transferred to the Z-axis, so the Z-axis moves very smoothly. And this is then just placed on here, and once the threaded rod goes through the nut, the nut will lift and lower the Z-axis, and if there's a little bit of play in there, it's no issue. So that was that. Next, we want to put our threaded rod onto the Z-axis, and we just drop it in through the stepper holder and screw it down. I do have that ball bearing ball in the no bearing Z-axis idler, so that should be sitting down really nice. You can actually take this off and accelerate this. It doesn't have to be done all that way. As I always say, do what works best for you. And now that we're at the bottom of things, we've got the Z-axis mounted, and it's turning pretty nicely. Very good. The next part we're going to fix down is part 1 of the extruder, the extruder mount. For that we need 3 M3 by 10mm screws and 1 nut. Where did my nuts go? One nut, and the first thing that we want to make sure is that this part is cleaned off. We should test out that the extruder fits in here before that, and we must make sure that the Z-axis probe fits the hole, and once all this is verified, we can put this together and mount it on the 3D printer. The first thing that we're going to do is we're going to place the screw and 1 nut into the mount for the probe, so that we can clamp it down once we put it in there. We can still put that screw in later, but it's a lot easier doing it now. And then we want to take the lower 2 of these holes and place 1 M3 by 10 nut into each and every one of them. And then we take off the belt holder for the X-axis and fit the lower 2 holes with the screws that go through the extruder mount. And that is what we're going to fix down on the 3D printer. Now, the 2 screw holes at the top remain unused until we put the extruder in, but since we'll have all the wires dangling once it's in, we're going to do that a bit later. And we tighten this down nice and easy. And now our 3D printer has an extruder holder on its X-axis. Nice and simple. So let's continue and add some steppers. So here we've got our 3 NEMA 17 steppers. Each of them is 1.8 degrees per step. and they're rated at about 1.7 amps. And all we need to do with those now is put them into the frame and just screw them down with an M3x10 screw. That is really a simple step. It's basically up to you where you want to thread the wires. I usually try to put the wire output as close to the profiles as possible, but you can do it differently if you want to. It doesn't really make a difference. So for example, I'm putting the wire output in this direction on this stepper because it kind of fouls on the profile and I don't want that. So next thing that I'm starting to do is I'm mounting the steppers. There's an Y-axis stepper, the X-axis stepper, and the Z-axis stepper. I'm putting each of those on with an M3x10 screw with an added washer at the top, because the bore and tap on these steppers is sometimes very, very unpredictable. So maybe you need to use 8mm screws or something else, or more washers. It's really unpredictable how deep the bore and the tapping is on the stepper, and it differs from one stepper to another. So use what is best for you. With these Long's stepper motors, I'm using M3x10 with an added washer. So now we have our X, Y, and Z axis steppers mounted. We're almost ready to start working on the electronics and the alignment and the belts. This is one of the most crucial stages of building the printer, because now we have everything in line. We're going to add the belts, and then we have to make sure that everything is perfectly perpendicular to every other axis, and that is what later on will really make the difference in quality. But this is the almost done frame, and you can already get a feel of how sturdy this thing is and how much load it can take, and for that, how fast it's going to be able to go. So take your time building this. These steps are really important for quality. Now, before we start threading the belt and adding more parts, like the pulleys for example, we need one idler that still needs to be mounted, and this one is mounted with an M5x30 screw and two washers on the side of the 3D print, two 5mm bearings, and finally a nut. We make sure to tighten this one down really well, because there's going to be quite a lot of load on this one, and it's in a position where it will flex a little, but we need this to remain stationary because it will be feeding the belt to the pulley, and the better we get this to align, the better everything else is going to be. In the next step, we are going to add the X-axis belt and the X-axis pulley. The pulley is one of those really cheap ones that you get in the 3D printer sets. Well, usually it's a set of 8 pulleys and about 3 to 5 meters of T2 belt, and that is quite enough for this project. I'm not going to tighten this down really well, it's just going to be so it's on and it can't slide off by itself. And then we need a bit of belt. This is T2 belt. I use that and I like it. And the belt is threaded with the non-toothed surface on the outside to the mount, and it's then inserted into the mount and wound around it once. And we wind it around once, and we give it one twist on the lower end and thread the top too. Doesn't have to be perfect, it just has to be in there. And once it's in there, we just cut it. We cut it off with a pair of snips. Now, as you can see, this is not good. This is too loose, but it doesn't have to be on super tight. You just have to make sure that when the motor's not moving, there should not be any movement in the head. It's actually easier to do when it's facing us from the back. And well, that's pretty nice. No vibration, snug. And once we have it like that, we can just leave it. We'll later take some cable ties and tie that down so it won't get loose. But very nice. As for the next step, we'll be doing the same with the Y-axis belt. First order of business is to add the pulley. Once we have the pulley, we take our belt and we thread the belt into the top of the belt holder, which is still not fastened 100%, but just stuck in there. Once around the stepper, once back, and then we thread it into the other side. And as before, we just need to make sure that it's in there, that it's not really loose. It doesn't have to be perfect yet, because we'll be tightening everything down in the end and making sure that there's no vibration in there. Can be quite fiddly. And very nice. It's already pretty good, maybe even a little bit too tight. And when we're done, of course, I'll remove the rest, but leave enough so it can be folded over, like on here. For the next step, we're going to add the inductive probe. I'm using an inductive probe because I'll be using a aluminium table. If you're planning on using a glass table or a heated print bed, you should be using a capacitive probe. This just goes in here and out the bottom to a point that the LED is up on the front. And as before, we're going to make sure that the distance is correct when we have the cold end and the heating element in, because that of course is dependent on the height of the probe. So this step is kind of important and a bit complicated. We need to make sure that the J-type extruder that we have has a PTFE lined throat, and the throat is this little piece here. And sometimes when you get them, you've got an all metal throat like this one. This is metal on the inside. And you want one that has a PTFE liner in here. The reason for that is if you have an all-metal throat, it will be transferring more heat to the cool block, and we need to exchange that cooling block connector, the throat, with one that is PTFE lined. Also, this is going to work better with PLA. So, the one that's in here gets removed, and we place one inside that has the PTFE liner in here. We set that carefully against the aluminium cooler. We make sure that the temperature sensor is properly mounted inside the heating block, and that the heating block and the heater inside are pretty even. And the heating block should not, the heater itself should not be extruding more than 3 millimeters on this side, or it's going to come in contact with our fan. So this goes back in here. Then we take our nozzle. We can choose anything from 0.2 to 0.5, and we can configure that in the slicer setting afterwards. When you screw this in, there should be a hairline still visible, like about 0.2 to 0.5 millimeters. And then we have to make sure that we take some pliers and fasten this correctly. Don't overdo it, but there needs to be quite a lot of load on here, or we're going to have a mess when we're printing. So now that we have our extruder ready, make sure that we can pull the cable to the back. Add this so the cables point backward. Add the top part. This should clamp down nicely. If it doesn't, you can add some electrical tape to make sure that the extruder can't move, and then we just screw this in and on with two M3 by 30 screws. We also need to make sure that the opening at the top is pretty much even. Doesn't need to be perfect, but it looks better if it is. And once the screws are all the way in, we carefully tighten it down, making sure that the torque is somewhat similar on both screws. And once that is done, we've got ourselves an extruder block ready to go. For the next step, we need to do a little bit of preparation, and I'm going to leave you alone with that one. We need to make sure that all the cables from the steppers are long enough to get to the ramps board. This includes the X, Y, and Z axis stepper. The Y axis stepper shouldn't be a problem, but the X axis stepper needs to have cables long enough to reach the ramps board, even when the printer is in the highest position. So you need to make sure that that works out. And we also need two limit switches, and I usually use these tiny electric push buttons, and they need to have two cables attached to one side. I don't know, I usually use yellow and white. It doesn't matter which way they're connected, but we need two cables. One will be connected down here, right in the middle, on the Y-axis, and the other one will be connected to the carriage on the X-axis, and its cable should be about as long as the cable from the probe. We're going to need these in the next step, and the stepper cables should also be long enough by then. This may require some soldering, or if you bought your steppers with very long leads and connectors at the end, this may be really simple for you. Now that the cables are elongated, and we have the cables for the switches and a cable for the fan, we can move on. So just for reference, the short home switch has a cable that is 20 centimeters long. The one for the x-axis is 80 centimeters long. The power cable is about 60 centimeters long. That one is for the fan. And the stepper motors are now 70 centimeters long. That should be enough. I didn't put anything on the end of here because I'm going to cut them off when I'm happy with their length, and then add some plugs. Now we can move on to the Arduino Mega board, and what I usually do is I remove the power plug that is in this location, because usually it hits on the power plug of the RAMS board. You don't have to do that, but it looks a bit better if you do. Also, I added all the jumpers to the X, Y, Z and E0 drivers. They're needed for the stepper boards. You need to make sure that there are no short circuits, like here for example. There's a pin that is bent and it's short-circuiting something, so just make sure to bend that out and make sure that these are all nice and straight. And we join the two of them up. And we can now put them inside the cradle. And to make sure that they stay there, we use some double-sided tape. I prepared a few pieces of that. One here. One in the other corner. Small one right down the middle. And two in the front corners. For this I use the relatively thick 3M VHB tape. It's not really cheap, but it's the best that I could find. And as you can see, it sticks like hell. Okay, now that we have that off, we can take the board and just really carefully put it in here. Push down firmly. And that's that. The two locations where we add the home switches are right at the side of the extruder holder. There's a small block there, and these little switches fit right above it, right onto it. And I'm going to use a drop of hot glue to fix that one down. And the other switch, its cables need to be bent flat, and this one will go right under the screw and the nut holding the Z-axis. No, that's the Y-axis, I'm sorry, the Y-axis. And if the Y-axis returns all the way, it's going to press the button. I know this is pretty simple, but it also works very well. So let's fix these. Number 1 and number 2. Switch number 2 is now placed right under the screw on the block. And the screw can press that button. And later on we can add another nut or a piece of pipe, and it can make sure that we get this button pressed down. It might have even been possible to put the switch a little bit lower on that, but it's fine this way. It'll work. So for the next step, we're going to prepare the TiVo Titan extruder. This is what comes in the box, and we're going to start by taking the top off. And we're going to remove these two pieces here, and we will fit a piece of PTFE in here that will go right through to the end of the holder. And for that we're going to cut about 25 millimeters of PTFE, and we're going to shorten it afterwards. So let's just start out with 25 millimeters. There we go. Put these together and we see that we're about 10 millimeters too long, and we're just going to keep removing bit by bit until it fits perfectly. And yeah, that's pretty good. So let's make sure that the PTFE catches the filament and guides it, and it can't get wedged inside the tube. And when we're done with that, we put it back together. We also need to make sure that the fastening set screw up here is about in halfway. If it's on either side, it is going to block the plastic and you're not going to get it to go together all the way. So we start with the screw that is holding on the clear plastic, and then we fasten everything down to the stepper. and make sure that it's somewhat tight but not overly tight, especially the screw that is at the pulley. This one needs to be in, but it should only be down and not be tightened too much, because the pulley is not going to work otherwise. And finally, we mount the extruder driver to the profile, the one that's part of the Z-axis, and we use two M5 by 12 screws and T-slot nuts to fasten it, and we make sure that it is about 13 to 14 centimeters from the top. Before we can start the wiring, we need to make us a PTFE tube to go from the extruder, from the heating block, to the extruder driver. I usually go for one that is as short as possible, and for the 250mm printer I'm going for 36 centimeters. And once we have that cut, we make sure that the ends are very clean, so the filament cannot get lodged inside or has any troubles getting by the edges, because we want to have this moving as smoothly as possible. When we have that, we thread it into the extruder block down as far as it goes, and do the same on the extruder driver. Now, in the next step, we're going to gather all the cables we have from the extruder, the limit switch, the sensor, the heater, and the temperature probe, and we're going to join them to this PTFE tube, so we just have one long pair of wires going up. It makes it look extremely clean, and it also makes sure that the cables do not get bent so badly. We start by tightening down one side of the belt, with a cable tie. And we're going to need two cable ties in here, so we're going to place them before we fix down the first one. So we got two cable ties in here. The first one is going to hold the belt. And there's no need to use excessive force here. We just make sure that it's clamped down, and the second cable tie is going to hold all the cables going up on the PTFE tube, and this one doesn't need to be tightened very much either. We just make sure that everything is nice and tidy, and that we have enough slack on the back so that the block can get all the way to the end. And that looks kind of good. And we continue by placing another cable tie right at the beginning here, but here we join up all the cables that we have. And we just place the cable tie very loosely over it because there's still one cable missing, and that is the one coming from the fan. But we haven't mounted the fan yet because that is the next step. The little turbine fan that we're using is fastened using two M4 by 20mm screws, and they fit very nicely. And we don't need to tighten this down very much yet. We will go over these things at the end, but we can put a moderate pull on them. And we take the power cable and we also thread it through the cable tie that we just put on the PTFE tube. And all of these cables are going to be wrapped to the PTFE now using some cable wrapper. So at the point where the power cable from the fan ends, I'm putting the extension of the cable, which has a fitting plug, and we can just make sure that that is tucked away nicely. But it makes it very easy to remove the fan if it should ever break. And fans do tend to break. So once we're at the back of the drive stepper, we add its cable to our cable mass, and we also add in the cable from the Z-axis stepper, and we just bundle them up with a cable tie, and we can later on decide if we want to use cable wrap for that, or if we just want to leave it on the back of the printer like this, so it's easier to get to and to troubleshoot. But we can start shortening the cables and doing the wiring while we have all of this on the back of the printer, and we can later tuck it into the profile and just get it out of the way. Oh, we also can add the X-axis stepper, but we must make sure to leave enough slack so it can go all the way up and all the way down. So we just add this in here too. And I added the cable tie too soon, so I'll need another one. But of course you're not going to make that mistake. Now that all the cables are threaded correctly, I'm going to start soldering female pin connectors to these. 4-pin for the steppers and 2-pin for the end switches and the Yeah, that's about it. And I'll talk about the level probe later on. So, a word of caution when shortening the sensor wire. We need to remove quite a bit of insulation on the sensor wire, but the sensor wire needs to be long enough to reach the back end of the controller board. So rather leave it a bit longer and remove more insulation than make it too short. So I will be cutting off about 20 to 25 centimeters of this cable, and don't make this too short, because we will have to connect it to the 12 volt power on the front side of the board, and the signal with the 0 indication is going to the back side of the board. So we need to remove quite a bit of the insulation here. And be careful not to cut the wires inside. Yeah, like this. Now this cable has kind of a funny color scheme. You should be aware of that. Blue is minus, brown is plus, and these need to go to the front of the board, and black is the signal, which goes to the back of the board. Just make sure you know this. We will put two 2-pin female connectors onto this end and that end, and they will make sure that we know when we've reached the 0 position. Now that the RAM board is prepared and I've already mounted the drivers, when mounting the drivers it is important to set them to 1/16th step. So 16 half steps or micro steps for 1 step. This is done by setting the jumpers on the pins below the driver board. And the configuration is different for the type of driver board that you have. So you need to figure out what you need to do for 1/16th micro stepping. For the A-type boards, it is usually by setting all the jumpers. For the 8825, you only set the first jumper starting from the top and leave the other ones open. But you need to make sure that it's 16 stepping, because that is what the firmware is set up for, and that works best with the speeds configured. So the driver does not resort to quad stepping, which basically means you're not doing the stepping you set, but just a quarter of that. The next thing we need to do is we need to get the display mounted. If you don't have a display, you can just not do that, because you can just use the USB if you want to, and if you didn't get a display with your kit, then you do not need to do this. There's no change in configuration or anything. Now for the displays it is a bit complicated, because the display boards themselves are not very standardized. No two displays have exactly the same height, so the display box is kind of a, well, something in the middle of everything. The best thing to mount this, and we're going to use hot glue for that, is to take an SD card and put it in the slot. If you can get the SD card in the slot, then make sure that it's reasonably loose around it. If the SD card is too low, you need to cut the plastic at the bottom. If it is too high, you need to lower the board. That is the simplest way of doing it. What you also need to figure out is if the reset button is working. If you have too much of slack below the button, you can just put a little dribble of hot glue on here and it will bridge the gap. And that is what I'm going to do in this case, because there's a bit of a gap here. So let's prepare this. That's it, just a drop of hot glue, and let that get cold, and this should work pretty nicely in making that switch work a lot better. Just make sure you make it cool down all the way. So the next thing that we'll do is drop the board in here, test the switch. Yep, that is working nicely. add the SD card. And apply 2 blobs of hot glue at the edges in the front. And do the same in the back. And once the hot glue is on there, pull the board into the position that you need it for the SD card to fit. And we're done with that. I know this is a very simple way of doing it, but I've tried using screws and spacers and everything, and it's just so complicated to get everything in there. And this is a very simple solution that also works very well. While we let that cool down, we can add the riser from the display and the display cables to the ramps board, which is also pretty simple. Because it just goes on the front set of connectors and slots in at the connectors on the side. And everything is set. Now, if you want to, you can glue down the cables on this side with hot glue and also fix this cable to the profile. It's not necessary, but it just makes it a little bit cleaner. And we also let that cool down. So let's start wiring the steppers. One thing to keep in mind, never put the stepper connectors into the board or pull them out of the board while it's powered, because this can destroy the drivers. If after wiring you do not know which of the 2 stepper cables is the X or the Z axis stepper, just put a bridge, a wire between pins 1 and 2 and try to move the stepper. If it gets harder to move, then that is the stepper that you've just bridged. So this here is the X-axis stepper, and we mount the stepper cable with the red cable pointing towards us, towards the back of the board or the USB connector. We have the Y-axis stepper, which is coming from the Y-axis assembly. We mount this stepper the same way. Then we have the Z-axis stepper, and this stepper is mounted with the red wire facing front, so this will turn the other way. All right. Then we have the extruder stepper, which still has the long cable because it's the cable that was included with the stepper kit. We're going to roll that up later on, but now we mounted with the red cable towards the USB connector. And we'll take care of that wire later on. We have the home switch for the X-axis, which is going to go into the end switch port on the X-axis. The Y-axis home switch goes onto the Y-axis Endstop input, and the single wire from the Z-axis probe goes onto the Z-axis max switch. So there will be two left out, and that is where this goes. The power connector for that needs to go onto the 12-volt power supply that is right next to the first driver. The ground of that is on the right side. So this goes here. The last thing that we need to connect are the heater from the heating block, the power to the fan, and the probe of the temperature probe from the extruder and heating block. The temperature probe goes onto T0. The heater goes onto D10 or extruder 1 heater. And we just screw this one down. There's no polarity here, so it's quite simple to do. Make sure that you grab all the wires and there's no excess wire going out or creating a short circuit or touching anything else. And then we need D9, which is the extruder 1 heater, and we're going to use that for our not temperature control, for our controlled fan. And we need to make sure that the positive side is on the right and the negative is on the left. And that should be all our wiring. After we have that done, we can take the display controller and we can hook that up. And we're done with wiring. We can now tie down the wires so they don't touch anything. We can use a wire wrap for that or whatever, and just make sure that everything is really clean, and then we can start turning it on. So after we've double checked that all the wiring is the way it should be, that everything is set up correctly, we can power this on for the first time. Now, what should happen is the display should turn on and it should initialize and go to the status page. The fan for the extruder should turn on to full power for about 15 seconds and then ramp down. And nothing should start smoking, nothing should go really wrong. And we're just going to test that for now. So, power. The display is initializing. The fan turns on to full power and we can feel the air coming through there. And it ramps down. That is all we're going to do for now. So we disconnect it again and everything's fine. Now that we have the wiring correct, we have everything tucked under here nice and cleanly. We've turned it on. Now it's time to check the steppers if they're moving in the right direction, and we can check if they're moving 1 millimeter when they should be. For this we go into the position menu and we select X position fast. And we let the axis run. So this is the X-axis. Which is working nicely. We then go back and do the same for the Y-axis, which is also moving nicely. And then we do the same for the Z-axis, which is also moving pretty nicely. Once we're there, we can actually take a screwdriver or something made from metal and we can hold that under the Z-axis probe and we should see the status changing there, and we can make sure that that is working. The coolers here should not be getting hot. They can get a little warm, but they should remain safe to touch. And the steppers themselves should not be emitting any type of noise. No squeaking, squealing, no high-pitched whines. They should be silent. If they're not, you need to check the current going through the steppers. As a rule of thumb, for the A4988 boards, leave the pot centered. For the DRV 8825 boards, put the pot in the 3 o'clock position, looking at it like it's mounted here. So the flat spot should be at the 9 o'clock position, and the pointed edge that goes down through the pod should be pointing in the 3 o'clock position. As a rule of thumb, that is what you can use or what you can start with. Now that everything is moving, we can start getting all the parts here tightened down correctly. All these screws here, the screws in the front that we didn't fix down yet. We need to make sure that everything is perpendicular now, that the X and Y axis are perfectly perpendicular to each other, and we need to make sure that the X axis is parallel to the table. And once we have that, we can start really testing. Now is also the time where we add our build platform, and there are several ways we can do this. I usually have the all-solid build platform without the heated print bed, or For this one I have one with Metawell. Metawell is probably the best material to use, but it is really hard to get. Or if you want to use a heated platform, you will have to make yourself some mounts that go across these two screws and clamp down a 203mm heated print bed. But I don't really recommend that because you don't really need it. But you can still do it if you want to. After we've mounted the build platform and we've glued on the fan shroud, which we do by placing down the nozzle on top of the build platform and gluing on the fan shroud in a position so it's about 1mm away from the build platform, and we can just eyeball that. After that, we need to place down the Z-axis probe almost onto the build platform and go through a series of finding the 0 positions. That means homing the X-axis. And once we've done that, we're actually ready to start some test prints. Now, the only thing that you now have to do is you have to set the correct current for the extruder, which needs to be, well, it's an experimental process. You just have to find out what is the right current so it doesn't overheat and works well. And, well, basically then you're done. You can get into experimenting, you can get into printing, and everything should work out okay. You should also read up on using the homing function and auto bed leveling, which is all about using the G32 initializer before starting a print. But all of that is pretty simple. So right at this point, you're done building this printer. I hope I didn't miss anything, but I think we covered everything. Make sure that your belts are nice and tight, but don't over tighten them. They should not be moving on the bearings when the print carriage is moving from right to left. If it does, you can add a screw and a washer on the far right side and make sure that that doesn't pop off, but usually you don't need it. So, I hope you have fun with this. And if I missed anything, please leave it in the comments. Thank you very much for watching.